Nigel Franks leaned over a large, square petri dish, studying the ants roaming around inside. Middle-aged and slightly rumpled, Franks has a full beard, graying dark hair, and brown eyes, which on this day were framed by clear safety glasses. Like many scientists, he is single-minded in both work and dress, turning up in his ant lab in button-down shirts and khakis with such regularity that students take note. At least one has written a rap song about him. It begins, "Ugh, what? Ugh. My name is Nigel R. Franks. I study ants. I hang out in my laboratory wearing khaki pants." Franks had shared the tune with me because it made him laugh, and also because it contained verses that cleverly summarize some of his key observations about ants, the most important being, "They're more than the sum of their parts." "It's not a mystical saying," Franks said about that phrase as he set up an ant experiment for me to watch in his lab at the University of Bristol in England. "It's the definition of a complex system, which is something that is more than the sum of its parts." Animal societies, such as ant colonies, are complex systems. An individual ant may seem very simple and inconsequential, but by working together, individual ants create highly complex societies. They also solve problems together that they cannot solve individually, although they live in decentralized societies. They don't have a leader, and they don't have an overview or blueprint of what they're trying to solve or accomplish, Frank said. So how are they able to form their complex societies? That's what I'm working on with my experiments. Over the past decade, Franks has produced a steady stream of both groundbreaking and controversial research about how individual ants make the decisions that produce a colony. Decision-making in groups, whether ant or human, is increasingly a hot research topic in everything from computer design to election committees to armies, and Franks is regularly sought out as a speaker. When the ants make decisions, they tend to follow what Franks calls simple rules of thumb. And the ants' rules, he said, can actually be represented by algorithms, those instruction sets that guide computer programs to predictable results. Franks and his students decode the ants' decision-making rules and reduce them to algorithms via experiments they conduct here in his lab. They can run multiple experiments every day, even in the depths of an English winter, thanks to the room's tall, oversized windows and an overhead array of bright fluorescent lights. Together, the two light sources convince the ants that they're living through an endless summer. Even though it was a gloomy autumn day outside, the ants in Frank's lab were going about their tasks as if it were July, just as those in the petri dish were doing. They had no way of knowing that their peaceful little world was about to change.